Hi everybody, how's it going? Nice beautiful day in the windowless room. So we're going to just have like 30 minutes. So what we're going to do is we're going to talk about taking an existing legacy enterprise, 100-year-old company who had a data warehouse and ETL processes and the entire analytics platform, the entire data ecosystem for every application, every database, everything that existed throughout this organization was taken from a data center and moved to the cloud. The scope of what we're going to talk about was really just the analytics platform. So data warehouse, ETL, BI, reporting, all of that stuff. So just a quick little word about who I am. So I'm Joe Caserta. Anybody in the data warehouse world, I wrote the data warehouse ETL toolkit with Ralph Kimball back in 2004. And built this company in 2001. And all we do is this type of stuff. So lately we've been doing cloud computing, building data lakes, building data warehouses. We're doing ML, dabbling in AI, we'll talk a little bit about that. But really, we're all about data architecture and everything around data architecture. We can make this as interactive as possible, but we only have 30 minutes, and I am from New York, so I'm kind of a fast talker. If you need me to repeat anything, just say, hey, Joe, slow down. Can you repeat that? I like criticism, that's how I get better. So tell me what to do so that you're happy and you understand what I'm saying. And if you need some clarity based on what I'm saying, then there's probably somebody else in the room. So don't feel bad to ask as many questions as you like. So the solution we're going to talk about is a company that moved to Google Cloud Platform. But what we're going to talk about really is kind of cloud agnostic. Doesn't really matter. We're going to talk all about the cloud components because it's a real life story. I want to tell you exactly what we did, how we did it, when we did it, how long it took, all of that stuff. But what we did could have been done on AWS, it could have been done on Microsoft Azure, it could have been done on IBM Cloud. It doesn't really matter, right? The really thing to take away is going from your on-prem data center solution to the cloud, period. And we're picking one story, but we've done this many, many times for companies, financial services and media and entertainment, higher education, retail, publishing, nonprofit, mountain resorts, doesn't matter. Whatever vertical you're doing, whatever kind of security requirements you have, confidential data, all of it, you know, we could talk about any specifics where you may have some questions. So you may think, you know, why do we want to do this? You know, and when you ask any cloud provider, right, what are they going to say? You know, it's scalable, it's elastic, it's blah, 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 all of that stuff. None of those reasons is why we did this. We did this because the company was based in oh, I'm on the wrong slide actually. I'll continue the thought though. The reason we did this is because it was a New York City based company and the data center was in New York City and the real estate for that data center was, you know, it was just ridiculous that they were paying to store data on this very, very premium property in New York City. So they wanted to clear out the data center so they could lease it out and actually turn it into an asset rather than a liability. So this is not a model. This is actually the director of analytic systems and physically shutting down that box forever, right? The entire system, the entire floor shut down forever. So the entire data ecosystem was re-engineered and replaced with Google Platform Components. And you know, we just took care of all of the data warehousey type of stuff, right? The reporting, and we'll talk about all the different components. But as we were doing what we had to do, there were other organizations throughout the enterprise taking care of their specific responsibilities. And it was a big, giant concerted effort to get all of this done in a pretty short amount of time. It took about a year, maybe a year and 3 months, to get everything out of the data center and move into the cloud. Any questions so far? Cool.
I don't mean to jump ahead, but what kind of a footprint did their ecosystem have? I mean, was it 10 terabytes or was it
There was
500 gig?
It was hundreds of terabytes, hundreds, yeah, across all the different systems. You know, for our system, I tend to think in rows, you know, and our major fact table had billions of rows in it. It was big. It was big data. And we'll talk about exactly what that architecture looked like. So yeah, I jumped ahead a little bit, but they moved not really for the scalability and elasticity and the cost and all of that, definitely important, but really, they were really in the business of like managing infrastructure and engineering the racks and like power systems and generators and, you know, conduits and cabling and lighting and dealing with the New York City unions to like install an outlet on the wall. Like all of this stuff was really significant. Time sink, cost sink, dealing with, you know, heavy duty air conditioning systems to keep the servers cool. It was a full-blown data center in their building. And managed services, and then of course the real estate, which was one of the primary reasons. So, you know, one of the biggest challenges or skeptics that was brought up in the early days was security. You know, how could we take our customer data and put it on the cloud? You know, be so vulnerable. And actually, preparing for this presentation, I actually did a bunch of research, but it wasn't real life my experience, so I took it out. But it was an interesting exercise that I did, and I analyzed all of the security breaches that happened in 2017. And, you know, some of you may know, like Walmart got hacked. What was the other biggest? Sears got hacked. Saks Fifth Avenue got hacked. Like there was lots of them. And what was the one you said? Equifax. Most of them were on-prem. Some of them were cloud. But that wasn't the thing. How a lot of them actually got hacked was through partners that they were actually working with. So, you know, like one of them was a chatbot service that you can actually outsource. And people put malware in the chatbot conversation, which penetrated the system, right? And that, whether you're on the cloud or not on the cloud, doesn't really matter, right? That's, you know, having protection against your data is still your responsibility, whether you own your infrastructure or somebody else owns your infrastructure. Many people argue that, you know, I hear it all the time, companies like Google and Amazon, like they have more people focused on security than most of your business's entire IT staff. Sometimes your entire organization in general. But that's no excuse to not worry about it. Your data is still your responsibility, you know, it doesn't matter. So what I did was and we're not gonna go every single one because we only have 30 minutes, but these are all of the things that don't go away, right? When you are moving to the cloud, whether you're on-prem or on the cloud, you know, having operational security, having intrusion detection, you know, safe employee devices and credentials, like all of that is still on you, right? It's all still on you to be able to do, whether you're on the cloud or you're on-prem. There are some things like the hardware infrastructure, the design and the provenance of your servers, like that stuff actually, like I would trust a Google or an Amazon or a Microsoft to do that job better than any company that I've ever worked with to do it on their own, right? So there's some places where, like hardware infrastructure, even service deployment, the inter-service communication and having encryption between all of your services, like that's the type of stuff that cloud offerings are really, really good at. But things like, operational security, user identification, authentication, login abuse protection, that's all stuff that you still have to roll your own and do it yourself. So, there's lots and lots of different components that are used throughout the cloud offerings. For our solution, we needed just some compute engines, some big data engines, data storage, and we also did some machine learning. These are the core components that we did. Compute engine is similar to like EC2 and AWS, if you know that area. That's just to run your processes. We did use container engines for deployment. BigQuery is actually where we actually built the data warehouse. So we replaced in this solution, it was Oracle, Informatica, Business Objects. All three of those things were sunset and shut with the servers. The original intention was we were thinking, okay, we're going to take all of those three things and lift and shift it into the cloud and just run it on the cloud. But after we started peeling back the layers of the onion, we started thinking, well, there was hundreds and hundreds of tables in the data warehouse, and there were hundreds and hundreds, if not thousands, of ETL jobs. And there were thousands of reports. And we were thinking, who's using all this stuff? So what we did originally, before we even started, is we did a rationalization kind of prerequisite project to figure out who actually is using this stuff. And why do we have, thousands of ETL jobs to load hundreds of tables? The math wasn't working for us. So the data warehouse that we were replacing was 18 years old, right? So nearly 2 decades, which is an amazing run, right? Data warehouse that lasts 18 years is pretty good. But what we learned is that, the company evolved over the past 18 years. So they would have processes that loaded tables, and then business rules changed. So they have processes that changed the processes that loaded these tables. And then the business rules changed, and they have processes that changed the processes that changed the processes of the loading the tables. And we really found out that there was just like this exponential growth of jobs that really were just correcting the last job. And if we just scrap it all, we could just have one nice, lean, easy to maintain job. Because what happened over the years is that it became so brittle that you were afraid to touch anything because you didn't know what affected everything else. So we actually had to go through the analysis and reverse engineer all the jobs, reverse engineer all the tables, and then talk to the users and say, okay, of these thousands of reports, so there were literally, I think there was over 1,000 reports. How many people think that all 1,000 were being used? How many people think more than 500 were being used? How many people think more than 100 were being used? Yeah. There were actually 27 reports. And it's kind of that's not completely true. So what was really true is that they would have a report that had a bunch of metrics on it, and then they'd have a report that's like for this region. They have another report for that region, another report for that region, right? And so they would have like 30 reports that were essentially the same report, right? Because back in the day, that's how you did it, right? Now, with modern data engineering and modern BI, you don't really need to do that anymore. So we were able to streamline down to actually 27 reports. And we took all of the data, all of the ETL, we put in Spark, because it was very high volumes, but we built all of the ETL in Spark, all of the data orchestration, we used Airflow, and all of the ingestion was in Google Storage, which is an object data store, and then all of the arbitrary queries, data warehouse, if you will, was done in BigQuery. And now it's very efficient, very easy to maintain, and highly, highly performant. Things that were taking, hours. Back to the scalability, elasticity, like all the byproduct benefits that wasn't really original intention. Now the company's actually seeing it, and it's amazing. BigQuery, for those of you who don't use it, like we can query a 3 billion row table and it comes back in seconds. It's really great. Okay. So this is the architecture that we used. This is the architecture we use everywhere. This is something that Caserta came up with as a company, I don't know, 7 years ago now. So, I sat in April's course a little bit this morning, and there was a little debate about, like, does a data lake replace a data warehouse? And always, like, in every conference like this, that debate always comes up. And the answer is no, it doesn't. So the answer is we have 4 tiers of data, and this is across the board. Whether you're on the cloud, on-prem, Google, AWS, staying in Oracle, whatever, it doesn't matter, right? But we want to have an ingestion area where we could receive all of our data. Typically, that's an unstructured environment, like an object data store on the cloud. Could be Hadoop if you're still doing Hadoop. And then we have a data lake. The data lake now will have a data catalog put on it. We'll do information lifecycle management. We'll do some light data quality and monitoring. And this is where we start doing some integration. So, if you're receiving data feeds coming from sources, typically those data feeds are just like strings of code, right? So we know a transaction happened for this product number, for this customer number on this date, right? And all these other ancillary codes that go along with it. Doesn't really mean a whole lot, right? In order for it to mean something, we need to enrich it with contextual data. And that all happens in the data lake. So in the data lake, we'll have data coming out of the warehouse, putting into the lake. We'll have data streaming in from external sources, batching in from external sources, putting it into the data lake. It'll be lightly governed. And then we'll have a data science workspace. So those data science workspaces, typically they are, in this case, they were in Data Lab in Google. But typically it's a Spark environment where you're building data frames, and you'll have access directly to the data in the data lake, and the interface is typically a Jupyter notebook. And that's where and that's where you can do your predictive analytics and building AI, whatever you want to do there, you can do there, munging and blending data. And then, typically the output of that is usually some really interesting scoring, like, propensity for a customer to go through attrition and taper off and leave, or, products that have a propensity to influence some of the products. Like, all of that insight can be created in a data science workspace. And typically the ILM for a data science workspace is about 90 days. After 90 days, it's ephemeral, the entire workspace goes down and it's gone. And what this does, it actually, and this didn't exist in the on-prem solution before we started. We created this because the reason why there were hundreds and hundreds and hundreds of tables in the data warehouse is that there were just all of this ungoverned information that was actually being copied outside of the data warehouse all over the place so that people could use it. Because this also came up in this morning's session, the life cycle to create a governed structure in the data warehouse took too long. Right? Once you go through the life cycle management of like collecting requirements and data modeling and governance and reports and the semantic layer, blah, 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 like months go by. And nowadays, there's no company that can tolerate that, 0. So what we have to do is we have to have a faster speed to value for providing data. So we allow data scientists and trusted users, they don't have to be a quote unquote scientist, trusted users can get data out of the data lake, put it in their own environment in a workspace that only they have access to, and then if they get some insight, then they can promote it through a governance lifecycle, and they can either go back in the lake or go into the data warehouse, or just get shut down and they lose it. And then ultimately, there is data in a data warehouse, so we have coexisting data warehouse and a data lake. The data warehouse is still fully structured, fully governed, and in this case, it was in BigQuery. Any questions on this? Yes?
Did BigQuery not have access to what we call the data lake?
Did BigQuery have access to the data lake?
Although that trusted, they could still query arbitrarily the data lake in the landing area, or they could just touch the fully governed data?
So you can have access to the data lake if you're a trusted user allowed to get into the data lake. But for the masses of the business, the thousands of casual business users, they were only allowed to go into BigQuery. They were not allowed into the lake. Yeah. Yes?
Does your data lake include external partners where you have external databases as well?
Does it include external partners, external databases?
Yeah, so you have internal on-prem solutions that you could easily put data into that data lake, but there are a lot of companies that does the SaaS model. How do you bring the external partner data as well?
Oh, so I think the question is, does all of the data live in the lake, or can you actually reach outside? So two things happen. So one is we get external data feeds, right? Every company that we work with, this is not really an exception, but we did receive external data feeds. Some of it could be streamed in. Most of it was actually batched in though. And it can sit in the lake. But in the data science workspace, and also what is missing here, because I didn't want to get into it too much, but we also had a microservices layer on top of it. So building those APIs, like a data scientist can reach into the lake and can also reach into external sources and munge it together within its own environment, right? But that data, just to be very clear, that data cannot be put into the warehouse or the data lake without going through the full data governance lifecycle. Any other questions? So this is just what it looked like physically. So physically, we received data. We received, so we were actually finished a little bit ahead of the rest of the organization. Eventually, the mainframe that whole entire application will also be on the cloud, and the mainframe is going to be put to pasture. But for now, the mainframe still exists, at least at the making of this slide. And then all of the other external sources, some of them were created in compute engines in GCP, and others, like the Oracle stuff, Oracle is not supported in GCP. So there's a new initiative going where we're actually going to re-engineer the Oracle stuff and put it into GCP without Oracle. But so all of that data comes in through an ingest server, a compute engine. Everything sits in the object storage, Google Cloud Storage, and then everything is processed through Dataproc, which is equivalent to EMR. It's just Hadoop, Elastic MapReduce kind of thing. But Dataproc, all we really do there is we run Spark. That's what we do. And we write all of our jobs in Spark. 100% of our ETL is written in Python. And it's all managed through Airflow. And we also have Cloud Functions. So every time we receive a new piece of data, then we're capturing all the metadata that we need about that data, and we're storing that as well. We're actually putting that into Cloud SQL, which is a Postgres database, just because it's easy, because it's almost like transaction-based. So it made sense to do it that way. And Cloud Functions in Google are similar to Lambda functions in AWS, right? They're serverless. They're based on some event, like the appearance of new data. It'll wake up, run its process, and then shut down. And it could run continuously if you're continuously running new process, landing new data sets. And then all of the data gets processed, goes through into BigQuery, and the next slide will explain why we have this. But the original plan was that we would use BigQuery for performance, but we would use Postgres for the enterprise data warehouse. And this is only because the people who were there couldn't get their head around not having a fully relational database to store your enterprise data warehouse. So the original plan was to actually have that. This was never actually implemented. We didn't do this. We actually, through working with the client, convinced them through evidence that you can actually do everything you need to do just in BigQuery. Between the Google storage, Object Data Store, and BigQuery, MPP, that is all you need. There was no use case required, except for maybe the metadata, and quite frankly, the metadata could be done in BigQuery as well. But we wound up having no use case where a relational database was required. So no Postgres was implemented. And then on top of BigQuery, we had reporting, we had standard BI tools. Looker would be a really good one for this. Looker, those of you who are not familiar with Looker, it's probably one of the better tools out there that's made specifically to run all of its processing within BigQuery. So it's highly performant, very lightweight. All the other ones, they like to take, you have this great big data engine, and then they take the data out of these engines and they put it in their own server to run queries. Doesn't make a lot of sense to me. You want to find a BI tool that's actually going to leverage the big data engine that you're using. So one of the biggest challenges here actually was not technical, right? It was easy enough to look at all of these ETL mappings, all the Informatica jobs, and go through and figure out what they're trying to do, talk to the users, and wind up ignoring all of the complicated logic in the ETL jobs, and just building what needed to be built. What was challenging, though, is getting everybody on board that this is actually the right thing to do, and trying to mitigate resistance. So what we had to do, and here, it's really these two. So what this is we tried to quantify all the reasons to actually move to the cloud, and then all of the reasons why people were resisting moving to the cloud. And we actually attacked them one by one. And this is a really good change management consulting, strategic engagement type of, separate from tech, nothing to do with tech. But what we had to do is we had to really focus very heavily on education, training, and mentoring, so that everybody involved, especially in IT, felt safe, right? Because if you're one day, you have a job, and your job is to maintain something you know nothing about, right? You're gonna get scared, and you're gonna push back. So what we did is we just kept them very, very close. We made them as smart as we were before we left, and now everybody there is still there, and everybody there is actually, we have just 2 people there for ancillary support. The entire ETL team, the data engineering team, the data model, everybody's fully on board, maintaining this thing 100% on their own, fully self-sufficient client. And that's it. I think we're exactly on time, right? So, any questions? Do we have 1 minute for questions? Anybody have a clock or a watch?
I noticed you had Tableau listed as one of your things. Was that in part of your
Tableau is
stuff, Ian?
everywhere. Tableau is everywhere. You can't get away from Tableau. Yeah. Tableau was part of it. It wasn't the primary tool that they used, but Tableau is definitely pervasive within the organization. Yes?
How much data are refreshing or feeding to the system
Sorry?
from the operating system or original systems? How much data are feeding or refreshing daily?
I don't remember the stats. It was in the 7 terabyte range or something like that. Yes?
So I think in banking regulation, one of the biggest risks, even other than security, what we talk about is just the market share. That, Amazon is servicing almost 50% of the market share of the cloud computing. So, and it's interesting that you chose Google. So is that a concern at all that there's all this data by one provider?
So AWS came out first, and AWS does have the market share. But if you look at growth,
Right.
Google is really right on the heels, growth numbers wise. The other reason why a lot of our clients are not going with AWS and going with Google is because Google has their hand in so many different aspects of business, like retail and manufacturing, they do everything. And a lot of our clients see them as competitors, and they don't want to give their competitors business. So that's why they're going with Google. They're also in healthcare now. It won't be long before they're doing banking, I'm sure, right? Yes, one more question.
How did we get over the concerns about security, privacy, cloud, public clouds, and all that stuff?
Yeah, so it's education. It's education and evidence. If you show, here are other companies just like yours that are doing it. Here's all the vulnerabilities and the breaches that have happened that are not on the cloud. And here's how we're going to attack it, right? One step by step, using that slide as a guide. Here's the actual solution with it. And through that education, made them feel comfortable to move ahead. All right? Thank you, everybody.